Greetings, welcome to a video on how to use the iPhone app to do regression, in particular how to do section 4.4 of our textbook. So let's look at practice problem number 9, it's grist for the mill here. The following table shows the number of newspaper subscriptions in Middletown, USA, where T represents the number of years since 2002, T equals 0 in 2002, and S of T represents the total subscriptions for each year measured in thousands. So probably a good place to start here when working on a problem like this, let's go over to just the whiteboard for a minute, is to come in and make sure you understand what the T years represent. So T equal to 0, well that's 2002, so I'm going to put a 2002 up above it here. I'm going to shrink my pen down just a smidge to make it a little easier to see here. And then 2 years later, that's going to be what, 2004? And then 4 years later, that's going to be what, 2006? 6 years later is going to be 2008, and then 8 years later would be 2010. Okay, so keep that in mind. We're going to need that in a bit. And also keep in mind that this is in thousands. This is 45,000. This is 448,000, okay? All right, let's go ahead and get onto the calculator here. Sorry, wrong key there. So let's go ahead and show how to enter that data into the calculator. Okay, press your stat key. And when you press the stat key, you'll be given the options of edit, etc. So let's go ahead and click on edit. And you can see I've already gone in and entered the data in L1 and L2 respectively. So let's say, just for example, let's put some numbers in L3. And say you had a list that had numbers in it and you want to get rid of it. Well, to get rid of that list of numbers, go up and highlight the list name, in this case L3, and then press the clear button. When you press the clear button, it's not going to do anything yet because it's saying, are you really sure you want to do this? Now I have to press enter. When I press enter, it deletes all of the items in there. Okay, cool. So now we've got our data in there. And the first thing that it wants us to do is use our calculator to determine the equation of the regression line rounded to 2 decimal places. Well, to do that, press your stat key. And under stat, you'll see that there are menu items, edit, calc, and test. We're going to want calc. So press the calc button. And under calc, we're going to go to option number 5, which is linear regression. Notice that if you hit the I, it'll give you all sorts of information on how to use linear regression. It can be very useful for you. Okay, so make sure that you take a look at that. Let's go back now to get back to the actual regression. So we'll select that. Notice it pastes the command to the home screen. This is graphic calc 83 because it runs just like an 83 does. And this is the way it does it on old dog 83s. Now, the only thing I would want to add onto this is the name of the regression equation. In other words, where do I want to store my regression equation? The default for the X list and the Y list is L1 and L2. So if I don't put anything in there for those, it'll assume that I put my data in L1 and L2. And if you'll notice, that's what I did. I put them in L1 and L2. Smart idea, okay? So let's get back out of here, go back out to the home screen. Let's go do that one more time. Sorry, I kind of take you down a rabbit hole here. So let's go to Stat, Edit, Linear Regression, AX plus BY, and then go hit VARs for me. And then from VARs, hit YVARs. From YVARs, hit Y1. And notice it appended Y1 onto the end of it there. Now, when you press an Enter, it just took that regression equation, y equals negative 51.65x plus 448.2, and stored that into our y equals menu. Let me show you. See, it's plugged right in there, which is very nice. Okay, so let's go ahead and start answering some of the questions here. So write down the regression equation. So y equals, let me go ahead and bring my pen thickness back up just a smidge because it does make it a little easier to see. So let's try that again. Here we go. Okay, so y is equal to, let's see, it's negative 51.65 x plus 448.2. Okay, now they want it in S of t, so you get to write it again, but this time in function notation. So S of t is equal to negative 51.65 t, not x, plus 448, my 8 a little better this time, 0.2, okay? All right, so far so good. Now, so use our graphing editor to create a scatter plot of the data and the linear regression equation. Be sure and use an appropriate viewing window. Okay, so let's go back to the calculator. So how do I get the calculator to actually put this graph on for me? Well, you notice on the Graph and Calc 83, excuse me, there's no plot 1, plot 2, plot 3 across the top row like there is on a regular 83. No big deal. Super easy to do here. Hit second y equals, which gives you the stat plot menu. And now notice those little X's over there. I'm going to hit the X on the first one and turn on the first plot. So now the first stat plot is turned on. The default is a scatter plot. It's set exactly how we want it, so we really don't have to mess with anything else. But I do want to show you that if you click on that or touch the actual scatter plot, it gives you lots of different options. I can sit here and scroll through the options of the different types of plots there are. The one we want is the one that was already there as the scatter plot. But just in case you go on to take elementary stats and use this calculator, you can still use it, okay? All right, so click on Done. All right, well, almost home. Now we want to graph this. Now notice that there is no zoom key on the keyboard. That's because the zoom key is actually in the graph. So we're going to press Graph, press Zoom, and press Zoom Stat. I'd already previewed this, that's why it came out quickly to the right settings. But if you need to get it to see this graph, you press Zoom Stat, okay? All right, cool. So let's come in here now. They want us to make a decent copy of this onto our homework sheet. So let's go ahead and do that. So we'll come back over here. So let's draw ourselves an S of T axis and a T axis. So this is S, this is T. And notice that we've got a point here. We've got, let's put it on the, since I have the option of changing color, so I'm going to go ahead and do that. So let's see, let's go with red here. There we go. Okay, so let's, you can do it. Come on, little computer. Sorry guys, this sometimes takes a bit to get my computer to cooperate. There we go. Okay, so there's the first point, the second point, the third point, the fourth point, and the fifth point, okay? And then we've got a regression line that, let's see, let's put it in blue for the regression line. The regression line looks not quite unlike, but similar to that, okay? So that's a pretty good representation of what I'm seeing on my screen. Now it wants to see the window settings, so let's go back to the calculator for a moment. So if I click on Done, that gets me out of the graph. And if I go back and I click over here, on second graph, that's where I get window settings on this calculator. Okay, there's a default key for window. You have to hit second graph to get to the window settings. So the X min, let's come back over here and write them down, negative 1.33. My X max is 9.33. My Y min was negative 22.2. And my Y max was 515.2. Okay, great. Based on your graph above, do the data appear to be exactly, approximately linear or not linear? They appear to be what? The data appear to be approximately linear. Looks like a line is doing a pretty good job of modeling the situation. Not exact, but good enough. Okay, let's go back to the black on here. So the explanation is the data look approximately linear. That's just fine with me. It doesn't have to get too flowery here. The data follow a linear trend. How about that? So one thing, just so you know from future work, or that you know in advance of future work, is that you need to always look at the scatter plot before you decide on what model to use. That's imperative. It's not an option. It is like probably one of the most important parts of any sort of model fitting, is to look at the data in terms of a scatter plot first. Okay, let's move on to the next page. Hopefully this is going well for you. By the way, if I'm going too fast, don't forget you can stop, rewind, watch it several times if you need to, okay? All right, what is the slope of the regression line, and what is the meaning in context of this problem? Okay, so if we go back and take a look at our regression line here real quick, just to remind ourselves, the slope, that's the That's the negative 51.65x, right? So in terms of this problem, what does that mean? Well, first of all, it's negative, which we notice from our scatter plot. If we go back and look at our graph here again, we notice that our number of subscriptions are going down with time. And intuitively, that makes a lot of sense. I mean, think about it. Not many people are getting their news off a piece of paper anymore. They're getting them off of these devices that we all carry, right? Excuse me. So the negative 51.65, what are the units on that? Well, let's think about this for just a second. Remember what we said earlier when we were looking at the graph, is that the horizontal axis is time. That's in years since 2002. The vertical axis, that's subscriptions in thousands, isn't it? So back here, this is going to be what? The numerator, which is, remember this is a slope. So this is a delta y over a delta x. So you can think about this as negative 51.65 over 1. So this is subscriptions. That's supposed to be a t. Let's just go subscript. Let's just make life easy here, okay? Subscript, and then I would put parenthetically 1,000 so that you know that. And that's going to be per what? Per year. So what that tells you is that the Middletown newspaper is losing basically what? About 5,165 subscriptions per year. If we go ahead and multiply that by 1,000, it'd be what? 5,165,0. Yeah, so it's going to be 51,000. So they're losing 51,000 subscriptions per year. So they're not getting any new subscriptions. They're losing subscriptions. Okay, I'll let you fill out the rest of that. What is the vertical intercept of the regression line, and what is its meaning in context? Okay, so the vertical one is 448.2. That's our B. Okay, so again, if you come back and take a look at our model here, we see that M is negative 51.65 and B is 448.2. Don't let the A confuse you. That's still in the my equals mx plus b position, right? So that vertical intercept, we need to also do what? Well, it's an intercept, so we really should report it back as an ordered pair. Is 0 by 448.2. So what does that mean? It means that according to the model, right, in 2002, the predicted amount by the model, so there's a predicted 448.2 thousand subscriptions. All right, I'll let you put in more detail there. I'm just going to give you kind of the rough outline of what you need to say in the problems, and you've got to fill in the sentences, okay? I'm not going to write the sentences for you. Use your linear regression, oh my gosh. Use your linear regression equation to estimate the total number of subscriptions in 2007, i.e. when t is equal to 5. Show your computations here and your final result. Okay, so what they're asking us for is what is S of 5 equal to? S of 5 is going to be equal to negative 51.65 times 5 plus 448.2. Let's go ahead and let the calculator do that for us. So let's come back over here and let's go negative 51.65 times 5 plus 448.2, and it looks like it was 189,095 subscriptions. Okay, so show your computations and your final results. So that's the number of subscriptions in 2007. So if we were to get it out of the thousands notation that was used here, it would say that what? You've got 189,950,000 subscriptions. Okay, all right. So use your regression line to estimate the total number of subscriptions in 2004, okay? So what would the number of subscriptions be in 2004? Remember that T is equal to 0 in 2002. So what that says is that T is going to be equal to 2 in 2004. So that says go find out what S of 2 is equal to. Now notice this is going to be slightly different than the number was on the table because this is a predicted amount, not an observed. The numbers in the table are the observed values. This is a predicted value that's produced by our regression model. Okay, so again, let's go back to the calculator, let it do the work for us. So we get negative 51.65 times 2 this time, plus 448.2. So the predicted is 344,900. So 344.9, which says that there is 344,900 subscriptions in 2002. That's the predicted amount. Okay, just to clarify, remember that the observed amount was 372,000. That's what we got on the table. This is our predicted amount using the predicting line. Okay. Let's go back to the last question here. Okay, last but not least, use linear regression model to estimate the year in which the subscriptions or the circulation amount will be 100,000. Round your answer to the nearest whole number. Reminder that S of t is measured in thousands, so S of t is equal to 100 here. Okay, so in other words, you would not try and solve with S of t equal to 1,000. Okay, so what you do now this time, we've been replacing t every time with the value. Now we replace S of t. So replace S of t with 100 is equal to negative 51.65 t plus 448.2. Okay, I'm not going to go any further with that. I'm going to let you solve that equation. I think you can handle that. So if you have any further questions on how to use Graph and Calc 83 on regression, do not be shy about posting questions to the Q&A forum, and I'll get back to them as quickly as I can.